Alright guys, in 6.3 we're going to be working with binomials, radical expressions. We're going to be looking at adding binomial radical expressions, subtracting them, multiplying them, and then eventually the last one, dividing them. Alright, so adding or subtracting radical expressions requires one condition, and that is, in order to add, you need to look at each radical and make sure that the index and the radicands are the same. If either one of those are not the same, then you cannot add or subtract them. Similar to like terms and not like terms. Alright, so let's get right to it. Number one, say if you're given the square root of 8 plus the square root of 49. Notice that they have same index but different radicands. So at the current moment, you cannot add them yet until we do some preliminary work. What I'm going to do is the square root of 8 can be rewritten as 4 times 2 because 4 times 2 is 8. And the square root of 98 is 49 times 2. Now 4 is a perfect square, so we know that this gives us 2. Alright? And also 49 is a perfect square, and that gives us 7. And then we have rad2 left inside. So now we analyze what we have accomplished after we simplify the first example. We look at these and we notice that the index are the same, they're both 2, and also the radicands are the same, they're also 2. So now we are able to add these two radicals together. When we add, we only add the numbers in front of them. So take 2 plus 7, alright, which gives you 9, and you leave the radical 2 alone. And so 2 rad2 plus 7 rad2 is 9 rad2. Awesome, very good. Let's go on to subtracting radicals. They have the same index, but the radicands are not the same, so right now you can't subtract them until you do some preliminary work. 81, the largest perfect cube that goes into 81 is 27, so rewrite 81 as 27 times 3, that's 81. The largest perfect cube that goes into 24 is 8, so 8 times 3 is 24, so rewrite 24 as 8 times 3. Now, we know that the cube root of 27 is 3, so the first radical, we got 3 cube root of 3. So this 27 give us the 3. So this 27, the cube root of 27 is 3. Alright? Minus, similarly, the cube root of 8 is 2. So 2 cube root of 3. So I'll highlight that for you so that you can see. Alright, that is 2. We can now subtract these because they have the same index, they're both 3, and they have the same radicand, which is 3. It's a coincidence that the index and the radicand are the same, but they do not have to be the same in order for us to subtract. Alright? So in this case, we're going to go ahead and subtract now 3 minus 2, and 3 minus 2 is 1. So you got 1 cube root of 3, or you can just write that as the cube root of 3. So either way. Okay, very good. Let's go ahead and add these two radicals. Now, these two radicals present even a bigger challenge to us. First of all, we notice that their radicands are not the same. And in addition to that, we know that we will need to rationalize the denominator. So it's a combination of two things that we're going to have to do. So I'm going to take the first radical, and I'm going to split that up as the square root of 32 over the square root of 3. And then I'm going to take the second radical, and I'm going to split that up as the square root of 2 over the square root of 3. Now I have to remove the radical in each expression before I proceed. In order to rationalize the denominator in the first expression, I would need to multiply this by cube root of the square root of 3. So multiply top and bottom by the square root of 3, in order to make the denominator go away, in order to remove the radical in the denominator, I would also need to multiply top and bottom by the square root of 3. Alright, now this expression, rad3 times rad3 is going to be 3. Multiplying these together, we're going to get the square root of 96. Okay, plus, you know what, guys? I'm going to leave it like this for now. I'm going to leave it as 32 times rad3 for now. So 32 times rad3. Okay, and then over here we have rad3 times rad3 is 3. And then this we can multiply these together because 2 and 3 are not perfect square and their product is not perfect square either. So go ahead and multiply them together like that. The reason why I chose not to multiply this together is because I know that 16 is the largest perfect square that goes into 32. And it's easier for me to identify 16 when the numbers are small. So for this first radical, and by the way, we have a common denominator now, so there's no reason why we can't use a bigger fraction, because when you add, you keep the denominator. Alright, so 32 is 16 times 2 is 32. So 16 is a perfect square. That means 4 is going to come out. So 4 rad 2. Alright, this gives me 4 rad 2 times rad 3. That's rad 3. And then we got a rad 6 over here. Alright. Now rad 3 times rad 2 is rad 6. So 4 rad 6 plus rad 6 over 3. We can add the numerator because you have your radicand being the same, you got your index being the same. So when you add, you only add the numbers in front of them. 4 plus 1 is 5. So we get 5 rad 6 over 3. Okay, 4 plus 1 is 5. Rad 6 over 3. There you go. Alright. It's not an easy problem, so if I were you, I would either pause the video, redo it one more time so that you can understand the process a bit more clear. Alright, now the last thing we're going to do here in the last 4 example is to show you how to multiply and divide binomials that contains radical. The good news is multiplying binomials that contains radicals is pretty simple. All you have to do is FOIL. So, example 4, let's go ahead and FOIL this. To FOIL, we take 4 and we multiply that with 3. And 4 times 3 is 12. Okay. We take 4 and we multiply that with the next term in the second binomial. When you multiply 4 with the number that's outside the radical. So 4 times 2 is 8. So plus 8, rad 7. Awesome. Repeat the same procedure for the next term. So rad 7 times 3, that's going to give us 3 rad 7. And then rad 7 times 2 rad 7. Now this is pretty interesting. So rad 7 times 2 rad 7. Alright, rad 7 times rad 7 is actually 7. So be careful and work this out slowly. Alright, let me know tomorrow if you can't see this. But rad 7 times rad 7 is 7. Because think about it, rad 7 times rad 7 is really radical 49. And the square root of 49 is 7. So rad 7 times rad 7 is 7. And 7 times 2 is 14. So this expression is 14 plus 3 rad 7 plus 8 rad 7 plus 12. Alright, 12 plus 14, that's 28. I'm sorry, 26. 8 rad 7 plus 3 rad 7, that gives us 11 rad 7. And there we go. We have multiplied 2 binomials that contain radicals. And we got another binomial, which also contains radical. Alright. Awesome job. Example 5, 6, and then 7. Okay. So example 5, we're also multiplying 2 binomials, but I want you to notice something. these two binomials are actually kind of special. They are what we consider differences of squares. So when we multiply them, we can use a shortcut. Instead of FOILing, we can use the fact that a minus b times a plus b can be, the result can be found by taking a square. In other words, take the first value, take the first term squared minus the second term and then squaring that. Right? So this is a review of chapter 4. We did this in chapter 4. Alright, so we're going to apply this formula to this pairs of binomial to save time. Our a in this case is 4 rad 5, so a is equal to 4 rad 5. Our b in this case is 3 rad 2. The formula involves a squared minus b squared. So we're going to go ahead and take 4 rad 5. We're going to square that and then subtract that to 3 rad 2 and then square that. Now when you square 4 you get 16. When you square rad 5 you actually get 5. This was the first property in section 6.1. When you square 3 you get 9. When you square rad 2 you get 2. This gives us 5 times 6 is 30. And therefore with the remainder of 3 makes it 80. And that makes it 18. So 80 minus 18 is 62. Alright. One thing I want you to walk away from example 5 is when you multiply a binomial, when you multiply a pair binomial where they differ only by a sign, you actually get a number that's without a binomial. I'm sorry, you get a number that's without radical. And that's one of the tricks that we're going to use when we're trying to simplify or when we try to divide binomial radicals. Alright? Also, I also want you to understand that this binomial right here is the conjugate of this guy. So another way to think of example number 5 is if you take a binomial containing radical, multiply it by its conjugate, you will get a value without any radical. Now that's going to kind of help us take care of examples 7 and 8, because in example 7 and 8 our goal is to rationalize the denominator. Our goal is to divide these binomials without leaving any radical in the denominator. So the trick here is to look at the denominator, which is 3 minus rad 5, and we're going to multiply this with the conjugate of 3 minus rad 5. The conjugate of 3 minus rad 5 is 3 plus rad 5. Okay, so we need to do that to the bottom and the top. And now we just go ahead and multiply them straight through. So I'm going to work with the numerator, the denominator first. Again, this is a special product, so I don't have to work hard here. I know that the answer for the denominator is going to be just 3 squared minus rad 5 squared. A squared minus b squared, which is going to give me 9 minus 5, and 9 minus 5 is 4. See? So by doing this, I'm able to remove radical from the denominator. Unfortunately, in the numerator, I do have to work hard. So I have to FOIL here. So 3 times 3 times 3, that's 9. 3 times rad 5, that's 3 rad 5. Okay. Rad 5 times 3, that's 3 rad 5. Rad 5 times rad 5 is 5. So now I'm going to go ahead and combine the terms together. So 9 plus 5 is 14. 3 rad 5 plus 3 rad 5, that's going to give me 6 rad 5. And now I'm going to go ahead and simplify what I can. In the numerator, I can factor out a 2. So I'm going to pull out 2. 7 plus 3 rad 5. The denominator contains a 4. So these two can be simplified or reduced, leaving us with 7 plus 3 rad 5 over 2. Alright, very good. Let's go on to the last problem. 2 rad 7 minus rad 3 over rad 7 plus rad 3. Why don't you guys do this problem, and we're going to go over this problem in class tomorrow, and you can check your answers with my answer tomorrow in class.